welcome to the stage.
Hi, I'm excited to tell you today about Facebook's fiber optic systems, how we're connecting the planet. As you know, more than 80% of Facebook's users are outside the US, so certainly this submarine system is critical to communicating with them. Let's take a tour of the systems as we pan out from our West Coast location. See several fibers going to APAC, but let's first look at the Atlantic fibers. You can see several fibers going from the US to Europe to connect to our users there, as well as our 3 data centers. I'd like to highlight one of those systems in particular, Maria, which is a joint project we did with Microsoft and Telefonica. And actually, at 160 terabits, this will be the largest capacity system in the world when it's turned up. It's actually just been laid in the ocean and will now be turned up over the next 2 months. Let's now pan over to our APAC cables. You see again the fibers coming off the West Coast. Our current submarine cables go to Japan, but for network diversity reasons, we want some more southerly cables in the Pacific, and we're working on 2 new cables from the US to Hong Kong. One of them is PLCN, and that's in collaboration with Google and an APAC partner. So PLCN is very exciting, and it's the most aggressive submarine system ever planned. At 14,000 kilometers, it'll be the longest submarine system in the world. It's twice the optical bandwidth of any submarine system in existence. And using the L-band, and at 150 terabits of total capacity, it will eclipse the current record of 60 terabits, which was set just last year. So there's truly a wave of data coming to the APAC region. Now, I wanted to give you an idea of the scale of these projects. These are massive projects and involve a lot of coordination between Facebook sourcing, TPM, and engineering folks. You can see the hair-thin strands of glass fiber on the left panel. That's where all the action, where all the information is sent. The bulk of the cable is really strength members and the copper conductor, which actually powers all the undersea repeaters or amplifiers shown in the third panel. And once the fibers and repeaters are integrated, they're loaded into the hull of a massive ship. And see that poor guy at the bottom? He has to spool the whole thing. But when that's done, the cable ship sets sail on a predetermined, well-surveyed route and lays the fiber on the ocean floor. In shallower waters, there's a sea plow that can go bury the cable to protect it from ship anchors and other external aggression. Finally, it's landed and connected to the station. So in Infra, we're working on several projects to both increase the capacity and lower the cost per terabit of all this transmission. One of these techniques is called probabilistic constellation shaping, and we're working on this in conjunction with Bell Labs. Basically, it's an information coding technique which allows us to increase the amount of information very close to the laws of physics, that will a certain amount of information within a certain bandwidth. It's called the Shannon limit. We're getting very close to that with this new technique. With Bell Labs, we did a trial. We set new capacity records across the Atlantic, basically doubling our capacity. We're also driving systems towards lower cost. It turns out we can save tremendous money, say, on the cable. The 2,000 metric tons of copper in the cable can be replaced with aluminum at substantial cost savings. We actually can go to lower cost repeaters, lower cost fiber, faster methods of deployment. So we're trying to reduce system costs by 40%. So really, the Facebook submarine team is really impacting and changing the conservative industry. We're building out a vast network of new fiber systems that allow us to connect the planet. And at Infra, we're working on new projects to both increase the capacity as well as lower the system cost. This will allow us to increase network diversity as well as connect to underserved areas. Thank you.
Ladies and gentlemen,